June 1943. On an airfield in southern England, Royal Air Force pilots stand beside their Hawker Typhoons. Beneath each wing are 4 long steel tubes fitted with blunt warheads. They are not bombs, they are rockets. The weapon looks improvised. The aiming system is basic. But within a year, this simple design would become one of the most discussed air-to-ground weapons of the Second World War. This is the story of the British RP-3 rocket. In 1941, British forces faced a growing challenge. The armored vehicles had become faster and more resilient. Traditional bombs required near-perfect accuracy. Machine guns were ineffective against reinforced steel. Large aircraft cannons added too much weight and recoil for single-engine fighters. British engineers needed a solution capable of delivering heavy impact without heavy guns. The answer would not come from artillery, it would come from rockets. Rocket research in Britain had begun years earlier. At Fort Halstead in Kent, the projectile development establishment had been experimenting with solid fuel rockets since the mid-1930s. The principle was simple. Instead of firing a shell from a gun, attach a rocket motor directly behind it. Rockets generate forward thrust without recoil. They can be mounted on lightweight rails, and they allow smaller aircraft to carry powerful payloads. This thinking led to the development of the RP-3, rocket projectile 3-inch. The RP-3 was deliberately uncomplicated. On a steel tube, just over 3 inches in diameter, cordite propellant inside, 4 stabilizing fins at the rear, a detachable warhead at the front. The most famous version carried a 60-pound semi-armor-piercing warhead. When mounted beneath a Typhoon, 8 rockets could be carried at once, 4 under each wing. The result was an aircraft capable of delivering significant explosive force in a single pass. Despite its power, the RP-3 faced a major limitation: accuracy. The pilots aimed using modified reflector sights. They dove toward targets at steep angles. Release timing had to be precise. Small changes in angle, speed, or crosswind significantly altered trajectory. Operational testing later revealed that under ideal conditions, only a small percentage of rockets struck tank-sized targets directly. The weapon was powerful, but it was not precise. The RP-3 first proved itself at sea. Naval aircraft used it effectively against submarines and surface vessels. But soon, the focus shifted to ground operations. By the time of the Normandy campaign in 1944, rocket-armed Typhoons formed a core part of Britain's 2nd Tactical Air Force. A new system called cab rank was introduced. Aircraft orbited above the battlefield, ready to be called in by forward controllers on the ground. This dramatically reduced response time. Air support became immediate and flexible. During the Normandy campaign, rocket-armed aircraft became highly visible. German commanders later reported that air attacks significantly disrupted movement. Armored columns increasingly moved at night. Supply convoys dispersed during daylight hours. Post-war research teams examined damaged vehicles carefully. They discovered that direct rocket-caused destruction was lower than pilot claims. Yet the psychological effect was undeniable. The distinctive sound of low-flying Typhoons and rocket launches influenced behavior across the battlefield, and perception became as powerful as impact. One of the most important developments of the war was operational research. Teams of analysts examined battlefield results objectively. They compared pilot claims with physical evidence. Their findings showed that rocket accuracy was limited, but they also showed something else. Air power shaped decisions. It restricted movement. It altered timing. It reduced operational flexibility. Yet the RP-3 may not have destroyed large numbers of armored vehicles directly, but it influenced how those vehicles were used. The RP-3 did not disappear after 1945. It remained in British service into the 1960s. It equipped aircraft such as the Hawker Hunter, Sea Fury, and Meteor. Other nations adopted similar rocket systems. The concept evolved into more accurate and faster unguided rockets, and eventually into guided missile technology. The RP-3 marked a transition, from traditional bombs to rocket-powered precision systems. The RP-3 was not a perfect weapon. Its accuracy was limited. Its reputation sometimes exceeded its measurable results, but it represented something significant. It showed how engineering simplicity could solve complex tactical problems. It demonstrated how air power could influence ground operations beyond direct physical damage. And it marked the beginning of modern close air support doctrine. The crude steel tubes that once looked like plumbing supplies helped shape the future of air-to-ground warfare, not because they were flawless, but because they changed the way air power was used.